Okay, I've got a question from Jared there, but before I answer that, I'll just do a quick sound check. Can everyone hear me okay? Is everything okay? Yep. Thanks, Jared. Thanks, Liam. Okay, that's great. So he's got a quick question from Jared there. I'll get to these in a second, some assignment questions. So this week's week 6 lecture video is now on YouTube. It's not on the course webpage yet, but it's on YouTube. Okay, so if you just go to Mike's Java videos, you'll find it. And we might have a quick look at this example from the lecture as well. So this is one of the programs we talked about in the lecture where we had a simple method. And we passed through a string, and the string one got called, and a double one got called, and the Boolean one got called. So we saw polymorphism and overloading in action, and which method was called depending on the type of data that we passed to the method. And when we just passed a simple integer, that got promoted to be a double, and the double one got called. And when we just passed a simple character, and we saw that the double one should also get called as well. So I just wanted to prove to you that that was the case, just in case you didn't check it out at home or whatever. So here I'm just passing a simple character, which has got single quotes around it, so it's not a string. And again, we'll get the double one being called for that. And you can set. And Sanjin asked the question about whether we could set a character to be an integer value from the ASCII table. So if we go back to our ASCII table, so you can use these values here: 48, 49, 48's a 0, 57's a 9, 77's an M, uppercase M, and so on. So you can use those numbers there to set your characters as well. And then when you display that character to the screen, you'll still see the letter A, okay? Because Java knows it's a char piece of data, and Java looks for a char representation of it when you print it to the screen. Okay, so let's just run that. So we should see Mike, string Mike, double 45.45, Boolean true, double 45, double 65. And that's what we get. So double 65. Oh, sorry, for the last ones, we're printing out the character. We're printing out the character here. We're not calling the method. So I'm just showing that the character does appear on screen no matter what. Okay, so even when you set it to 65, it's still a letter A appears on screen. Is that okay with everyone? Anybody? Maybe you tried that on at home. Hope you did try it at home. For those who did, I'm really happy that you did and impressed. But just in case you didn't, I thought I'd reinforce that by showing you. So is everyone okay? Okay, we've got 7 people so far, and lots of silence. The chat window is very quiet. One last test we'll do. Okay, so see if you can work out what's going to happen here. What's going to happen for this one? Which method will get called? Will it be the one that shows a double? Will it be the one that shows a string? Or will it be the one that shows a Boolean or something else? Okay, so Byron says a string method. Thanks, Byron. Any other guesses? Or opinions? They're not guesses, they're opinions. Anyone else got a different answer? Okay, and Byron's quite right. Okay, so by putting a double quote there, that means that's a string, and whatever we add on, whatever we concatenate on from then on is counted as a string as well. So we're concatenating a character A onto a string, which makes it the string A. So really, that's what we're passing through to the simple method. So that's going to call the string one. Okay, same if we did this. If we did that, the string 45.45 will get passed through to the method. Okay, it's no longer a double, it's a string. Okay, and also this one. If we pass double quote plus true, then the string true would get passed through to the method. Okay, so the string version of the method would be run, not the Boolean version, and not the double version, and not the char version, or the double version, in other words. Okay, so that'll be the string versions of the methods that would be called. Okay, so that one there would run. So for each one of those, we'd see method takes a string followed by an A, followed by 45.45, followed by true, but they'd all be strings then on. Just a bit of exploring I thought you might find interesting, following on from the example we had. Okay, any questions on that before we move on? Everyone okay? Okay, good day. So assignment due is due tonight at midnight or nearly midnight, 11:59. And so in week 5 and week 6, normally I sit with students in class. I go around every student, sit with you in class and see how your assignments are going and see what you're stuck on, have a quick scan through what you've done, make sure there's no glaring issues. And I do that sort of thing. So I can't do it at the moment because of coronavirus. So has anyone got any issues or questions on their assignments? I've got one from Jared here. I'll get to this one in a second. Has anyone else got any questions or issues? Or I can't help you directly on your assignments, but what I can do is I can explore and work on similar topics for other problems. Okay, so if you're having a problem with user input, I can show you on another problem. If you're having a problem with something looping, I can show you on another problem. Okay, so has anyone got any problems there on their assignments? You can speak or type in the chat window. Okay, deathly quiet. We've got lots of quiet so far. Okay. 9 people in class now, so that's good. We're getting our numbers up a little bit. Okay, no one's got any questions on their assignments? No one's got any issues? Everything's okay? We had some questions on the forums lately, so if you had a look at the course forums, there's been some questions there lately on what you need to do for your testing, screenshots and that sort of thing. So keep an eye on the course forums. Okay, no other questions? Okay, we'll move on. And so quick question here. Would we get marked down for using try-catch in our assignment? Okay, now try-catch is all to do with exception handling. The try-catch. There's some other words as well as finally, and throw. But mainly when you think of exception handling, you think of try-catch. Now, if I'd marked the if I'd set the assignment and I was course coordinator and I knew someone worked ahead and done extra work and covered try-catch, I wouldn't mark you down. But I've got to say, Bruce is a stickler and he likes you sticking just to the assignment spec. Okay, he does like that. And in the past, when I've tried to allow things through that where students did extra, he's told me to deduct marks. So my advice to you would be to stick to exactly what the spec says. I'm sorry, but that's the way Bruce likes it. So that's why we've got to do it. Okay. So if you've got your try-catch there, keep the code because you'll use it for assignment 2, but maybe pull it out of your assignment. Okay, so good question from Jared. How else would I validate an integer input where the program would crash if I accidentally type in a letter? And that's just something we have to live with for now. Yep. So this is perfectly okay. So that's perfectly okay. Okay, so I'm sorry if I was a course coordinator, I like seeing students work ahead. But Bruce is on another campus where he's found issues where students try and work ahead sometimes. So he likes people sticking to exactly the spec. And there is a good reason for that as well. When you're working in industry and you're working on problems and you think, oh, they might like that if I add that in and I'll add that in and I'll add that in and I'll add that in. People get very upset about that. And they'll say, that's not what I asked for. Give me what I asked for. So you've got to be very careful about feature creep, it's called. Feature creep. Where you're adding little features that you think people would like and they didn't ask for it. You've got to be very careful of that. And You know, as programmers, as developers, we like doing that. We like providing extra and providing extra features, but you've got to check with people first. And so I think that's what Bruce is doing there. He's getting people used to working on the assignments and sticking exactly to the spec. It's fair enough too. Okay, so a question from Byron there. Can we check if the input is a certain type of variable? You can. You can, Byron, but we haven't done enough Java yet. So for assignment 1, the reason is we haven't done enough Java yet. So you can tell what people are typing in, and you can do extra checks and things. But we haven't done enough yet. So yeah, so just keep it simple. I mean, I know you want to go further and make it so it's really bulletproof, and that's really good. That's brilliant. But for someone, just keep to the spec for now. Okay. Okay. So no one's got any questions on our assignments. So there's nothing people want me to work on. Yeah, you happy to work on the tute questions? Okay, so no one's got any issues or questions on anything? Everything's okay? Okay. Okay, well, that's fine. So like I say, usually I come in and check people's work in weeks 5 and 6, just see how you're going, see if there's any glaring issues, have a quick look through your code, make sure everything's on the right track, give it a quick test. But I can't with coronavirus, so righto. So let's move on to the tute questions then. Okay. So question 1, what are overloaded methods? So we'll start with that one first. So there's sort of several questions here. And it says several questions. What are overloaded methods? Are methods with the same name which only differ in return type, are they valid overloaded methods? And another question B is, why do identifiers have scope? So something you might think about there is, what is an identifier? What does that mean? I don't know if we've actually used that word in class. So do you know what identifier means? And when you're answering questions like this one, think of examples. Try and think of examples where it proves or disproves something and use those in your answer. Okay. Anyone got any opinions on what overloaded methods are, or what's an identifier? Nobody? Ah, perfect. There we go. So got a great answer here. Thanks, Jared. Oh, Byron, sorry, Byron. So identifiers are names you give a variable. So if you say field or variable or identifier, then they all mean the same sort of thing, okay? And it could also be a constant. So a constant could be an identifier as well. Okay, but field, variable, identifier, constant, something like that. It's something we use to identify something that contains some data. What are variables or fields have scope? What do you think they brought scope in? What's the important thing that it protects for or saves us from doing? Think about what would happen if there was no scope. If everything just had global scope, what would be the effect? Sorry. Hit the wrong key. Okay, so imagine a world where you're writing a program that's part of a big system. Okay, so you've got all these other classes that you're using, and you're writing your own little part of that to link in with those other classes, and everything had global scope. Okay, that means any data anywhere, any method anywhere is accessible. Okay, so any data. So that means you can change it. If you can access it, you can change it. And you can, or for data anyway. Changeable for data. And it's also corruptible data. So imagine you had a system where you had, like a bank has a big system, and you've got customer class and an account class and a interest rates class and a credit history class. And imagine you could write a little application that could bypass all the rules that are being enforced by those classes, and you could just change any data anywhere. Okay, so that would be a disaster. It would basically be the Wild West. Anything goes. No rules. No integrity. Okay, so if there's no scope, if identifiers didn't have scope, then everything would be global, and it would just be chaos, absolute chaos. That's why things have scope, so you can control where things are accessible and control where things are available. Okay, so you can narrow things down. So if something goes wrong, you can track it down to a small part of the program. Okay, it's not something else 15 classes away that changed it. It's something in this current class that changed it. Okay, so very important, that one. Why do they have scope? Very important question. It's a key part of programming, to control your scope. Limit things down as much as you can, so that nothing outside of that little bubble can change your data or corrupt your data. Okay, so we jumped ahead to part B, but what are overloaded methods? Anyone got any opinion on what an overloaded method is? Just say it in your own words if you want to. Try and think of examples. We just had an example on that prior example where we had the simple method, and we had taking a double and a boolean and a string. 11 people in the class, 11 people. Okay, nothing coming through. So overloaded methods are methods with the same name. Oh, there we go. Good. Thanks, Jared. Yes, that's a pretty good definition there. I'll put Jared's definition in. So methods with the same name that can accept a variety of inputs. That's a pretty good definition. They might also be able to. There's also the thing of context as well. So if I've got a menu and I'm adding a menu item, we haven't done this code yet, but I'm just showing you. So item, just showing you what the future holds. So you can use the add method to add a menu item to a menu, and you can use the add command to add a string to an array list. We haven't done array lists yet. We haven't done menus yet. I'm just showing you what you can do. Okay, so you've got multiple methods there. They do take different inputs. But also the context is also important. So it's not just the inputs that matter, it's also the context. So Java works out which method to call based on context. In other words, what's doing the calling and the parameters or arguments passed. Okay, so if you we'll go back to that example we're just looking at. Okay, so if you call simple method with a double, it looks for one that takes a double. If you take simple method call simple method takes an integer, Java looks for one that takes an integer. There isn't one, So it promotes the integer to be a double and uses this one. Okay, so that's just overloading in practice. Many forms of the same method. Many methods with the same name, and which one gets called depends on context and also the types of data that are passed to it. Okay, so if you're not sure about that, have a look at this week's lecture, and I talk about overloading and polymorphism for about, I don't know, I think it was about 20 minutes in the end, so I spent quite a lot of time on it. So have a look at this week's lecture if you're not sure. Okay, so question 2. Any questions on question 1 so far, or any of the people coming in a bit later got any questions on their assignments? Any issues, any problems on your assignments? No, everyone's happy? Okay. Question 2. So if you'd like to follow along with this one, we can all do it together if you want. If you want to open text pad and follow along. Otherwise, if you just want to watch and have a go later on your own, that's fine as well. Okay, so let's do that. So question 2, create a class called car, which has 2 private instance variables, make and price. Okay, I might copy this across into the other class. I'm not going backwards and forwards all the time. Okay, so I'll copy it into the top of this class, just so it saves me clicking on different tabs all the time. So 2 private instance variables there, make and price. So let's create those. So it says private instance variable. So it's a good idea to keep your data private, unless there's very good reason for it to be public, and there rarely is. So private, it's a string called make, and private double price. Okay, so we've done part A. That was easy. We've created a class with 2 instance variables. Now comes the more involved parts where we're filling in all the details, all the methods. So create the following constructors: a default constructor and a parameterized constructor. Does anybody want to tell me what I can type for a default constructor? How do I start a default constructor? And what would the code look like inside it? So if you want to fill in some details, please help. Or if you want to have a crack at the parameterized constructor and what the header would look like and what the body of the method would look like, if you can fill in any details, that'd be great. Anybody? No. Don't think anyone's keen at this stage, so maybe later. Okay, let's do the default constructor. So that's got to be set make to null. I don't like that, but anyway, and price to 0. Okay, so let's do that. So a constructor is public, followed by the name of the class. No void, no int, nothing like that. Public void followed by the name of the class. And we're doing the default constructor, which takes no parameters. So empty round brackets. It says set make to null and price. Okay. So we've done that. So that's our first part. We've done the default constructor. Anybody want to have a crack at the parameterized constructor? Or if you want to do one of the get and set methods, if you want to work ahead a little bit and do one of the get and set methods, do that, and I'll paste your code in there and give you full credit. Or if you want to do the toString method, or if you want to do the main method, if you want to do the main method where we're calling these other methods, you can do that as well. So feel free to work ahead if you want to. Just trying to get some input going, some some dialogue going. If you want to read it out on the microphone, you can as well. Okay. Let's do the parameterized constructor. So parameterized constructors, both make and price. So we've got one that takes both the make and the price, one that takes only the make, one that takes only the price, and use the default variables, default values for the other variables. Okay, so let's do the first one, the one that takes the make and the price. Okay, so public car, followed by string make. There we go, beautiful. So Byron's typed in some nice code here, and Jared said the same sort of thing. Yep, that's right, you're on the right track. I'll copy Byron's code in, because he's got the body of the method as well. And that looks great to me. Just missing some semicolons, but that's okay. Semicolon, semicolon. That's all pretty good. And Byron's done what I like as well. So yeah. So Byron said he's too used to Python. Python's So with Python, you don't have semicolons. Yeah. Where code belongs depends on the indentation. But we won't talk about that. And Byron's also done what I like too. So he's used the same names here and here, and price and price. And then to refer to the class one, he's done this.make equals make. So this make here without anything in front is this one, the parameter that was passed through. And this.make is the class one. Okay, now we won't call it create car, Byron. We'll just call it car. So it's got the same name as the class. So public car followed by. Okay, so keep all the constructors so they've got the same name as the class. Now I did show you a little trick in the lecture to save some code, and I showed you how you could reuse your other constructors. We did some overloading on constructors, and I showed you how you could use an operator here to replace these two lines. Anybody remember what the operator was that we used to invoke the other constructors or invoke another constructor? Starts with T. Okay, it was this operator. Remember this operator? And so if you want to call this constructor, you could pass through null and 0.0. Okay, and that would pass through null as the make and 0 as the price, and it would set the class data just the same as before. Okay, so you can reduce 2 lines of code down to 1. It's not a huge saving, but imagine you had validation and all sorts of things going on. This little code here could save you a lot of code. And don't forget your semicolons. Okay, so doing these shorthand tricks save you a lot of code when you're developing real classes with real validation and real processing going on. Here we're not doing any validation, so it doesn't save that much code. Okay. I also get in the habit of it because it's a great little trick. So now we've got the default constructor and a parameterized constructor. We need to do some more. Only accepts the make. So we might copy this one and pop it there and just accept the make. Okay, and we'll use this trick to pass through the make. So whatever make is passed through gets passed through to this constructor, and 0 is the price. Okay, so it said use default values, which are 0 or null for the other variables. Okay, and then the other constructor we need is the one that takes only the price. Okay, so we've got a default constructor that sets make to null and price to 0. With a parameterized constructor that takes just the make, and it sets the make to whatever the make is and the price to 0. Then we have another parameterized constructor that takes the price and sets the make to null and the price to whatever's passed in. And then we've got another parameterized constructor which does all the work. This is our workhorse. And it sets the make to whatever's passed in and the price to whatever's passed in. So no validation going on. So this isn't really what we do for a real class in industry or for a client. We would have validation going on. The price can't be less than 0. The price can't be less than $1 million. It can't be more than $1 million. The make can't be blank. All that sort of stuff we'd be checking for. Okay. So the question says, create a main method in our car class to instantiate objects of the class and to test out all of the methods. So we haven't done all the methods yet, but it's a good idea to get ahead and do a bit of testing as you go to make sure you're on the right track, because you don't want to end up with 1,000 errors or something like that. So compile and test often. So let's create our main method now. Okay, and it says do it in this class. So we'll do it in this class to start with, and then we'll move the main method to another class and show you how that works as well. Public static void, remember the main's public static void. String, square brackets, args. Okay. We want to create a car, and it's Byron's car. It's new car. Create another car. Jared's car. So that's the advantage of typing in the chat window. You get your name up in lights in questions. And we've got Liam as well. So Liam's also types in chat. So everyone who types chat gets a car named after them. Okay, so here we're not passing anything inside the round brackets. So for Byron's car, we're calling the default constructor. And for Jared's car, let's pass through a make. So he's got a Porsche. And the price was $99,999.99. Or that'll do, $9,999. You got a good price there. Okay, so picked up a good Porsche. And Liam's car, we just passed through the make, which was, you're doing all right. You're doing all right, Jared. You got a good deal. And Liam's car is a Tesla Roadster. That would be my dream car at the moment. So when we pass through a make and a price, the constructor that takes a make and a price is called. And when we call the constructor that just takes a make or a string, Java looks for a constructor that just takes a string, and there it is there, this one. So that one's called. Okay, so we should be able to compile and run our code. Control 1, Control 2. And nothing's being output because we're not showing anything to the screen. But you can see at least our code's compiling and it seems to be running. Okay, so now it's saying create, get, and set methods, or accessor methods and mutator methods. So you do that for every piece of data in your class, every instance field. So let's do that. Public void set name, pass through a string. Sorry, not name, it's make. Set make. Okay, so we need to set the class field to the value passed in. And so we can do that. This.make equals make. Then set price. And we'll pass through a price, which is a double price. And we know how to do that because we've done this.price equals price. Same code. So if there was validation going on here for setting the make or the price, we'd have that validation here and also here. Okay, which means we've got the same validation repeated in multiple places again. And I can show you a way around that, but we haven't done enough Java yet, so I don't want to confuse things. So if there's validation going on, you just have to validate it here and here and here. But later on, I'll show you, especially in the follow-on course, I'll show you some tricks where you can just say that validation and do it in one place. So we've got our mutators. mutators or setters. And then we'll do our getters, which are accessors. Anybody want to have a crack at a getter? If you want to have a go at get price or get make, have a go. And I'll just put a bit of a header up here to make our code a bit clearer. And these are our constructors. It's not a bad thing to do in your class files to put little labels like that. I put asterisks with mine, but if you don't want asterisks, that's fine as well. And then you can put all your constructors together, all your accessors and getters together, all your mutators and setters together. So accessors and getters, sorry. So no one's having a go at any of the. It could be people typing. I'll do the price one. So public something get price something. So we're going to fill in the question marks. So what sort of data is price? And it's a double. Okay. So we want to return a double. Okay, so the method return type's got to be a double. And we're returning price. And does the get price method need anything to do with its job? Do we need to pass anything in to get it to do its job? But we don't, do we? We're just returning the value of class data. So we don't need to pass anything at all. Okay. So the accessor methods or getter methods are usually very simple. It's just return, return, return. That's usually all they do. Then we've got get make. I'll keep them in the same order. So this is make and then price. So I'll do these in the same order. Public something get make. Return something. Okay, so let's have a look at what sort of data make is. Scroll up and it's a string. So the method's got to return something of type string. Okay, and it's returning the make. Does it need anything to do its job? Do we need to pass any data to the method to get it to do its job? And the answer is no. Okay, so get make and get price are done now. Okay, so we've got our accessors in place and our mutators in place. Okay, so now we can do some good stuff. Let's come down here and Byron's car dot set make. And what sort of car would you like, Byron? I'll let you choose if you want to type it in. I'll get it for you for a steal as well. I got your back. Set price for $8,999.15. Something reliable. Something reliable. There you go. So you got something reliable there. Okay, so now we're calling them mutators to change class data. And we didn't set a price to Liam's car. Okay, so we just called the constructor that took a string. So there's no price there for that one, so it's still 0 for Liam's car behind the scenes. So let's set a price. And a Tesla Roadster, I think, is about 120,000 Australian dollars or something. But let's say you got a good deal, because everyone's getting a good deal today. So you got a Tesla Roadster for 12 grand. There you go. I got your back. I got a good deal for you, Liam. Okay, so let's now display these data back to the screen. System.out.println. And we don't want to hold this data locally. The car class owns the data. So if we want to store the car data, it's in the car class. And if you want to retrieve the car data, we get it back from the car class. So we don't want to store local copies of Porsche Price and Tesla Roadster. We don't want to create local variables here to store all that. Unless they're temporary. Temporary is okay, but the owner of the data is the car class. So when we want to get the data back, we call the accessor methods like get make. Okay, and we'll just put a message out to the screen to show that's Byron's car. Okay, so we've got Byron's car and the make, getting the make of the car and also the price. Okay, let's run that. So we're creating 3 cars and we're setting the details for some of the cars in the constructors and we're filling in the blanks with the mutator methods. Okay, and then we're getting the details to the screen. I might even put a dollar sign there just to make it clear it's dollars. Control 1, Control 2. And you can see with the data coming out here. So Byron's car, something reliable, and the price was $8,999.15. Okay. Are there any questions on anything we've done so far? Is that all okay? Any questions on anything so far? Okay, nothing in the chat window. Okay, so let's say we want to format the data. So we want to line it up nice and neatly so it fits into columns. We'll do that last. We'll do that later. Okay, we'll do that later. And we've got Jared's car. And it's Jared's car. Oh, Jared's car. Jared's car. And then we've got Liam's car. Liam's car, Liam's car, Liam. And I can't help myself. I've got to line these up. I can't leave them messy like that. I've got problems, I know, but anyway. You go nice and neat. It saves you a lot of time anyway. Okay, so now we've got Byron's car, Jared's car, Liam's car coming out to the screen. Control 1, Control 2, and there we go. So we've got the details coming back. So something reliable, $8,999, a Porsche for $9,999, and a Tesla Roadster for 12 grand. So you got a great deal there, Liam. All right. So are there any questions on those so far? Anybody not sure what's happening? Anybody want me to go over anything again? Okay, everyone's happy? Cool. So let's do some formatting now of our data. And let's say we want this to be a column that's, say, 20 characters wide. Because when we run it, it's not really neat. The data's going in and out. See, it's going in and out. So it's not really that neat. We can make it much neater. If this is a report for a client or something, we want it to be super neat and line up in columns. So let's do that. Okay, so we want that to be, we'll use our string.format. We could use printf. And I'll talk about printf in the lectures. And printf's great, but we're going to be moving into the GUI world soon. And by using string format, you can also use it to output to the GUI. Okay, so we'll do everything with string format because that's more flexible. Printf is just to the console screen. Okay, so string.format, it's the same formatting flags, but it's just a bit neater to do string format when you're going to move to the GUI soon anyway. Okay, so it's a %s. Okay, and you can actually do this all with one string format. We might do it with one string format. Okay, so we've got a string coming out, and then another string, and then a floating point number or a double. So percent. We want 2 decimal places, .2f. Okay, so the first string is going to be Byron's car, the name of the car. Then the second string is going to be the make. So you put a comma. And then the third string is going to be the price. And I won't put the label there. I just put the car. I might move these two onto the next line so you can see it a bit easier. So we've got a string format. They're taking 3 bits of data, a string, and a floating point number. And then we pass in a string with a comma, and then a make, which is another string with a comma, and then the price. So the first string goes into that place, the second string goes into the second string place, and the floating point number goes into the floating point place. We need to end our string format command and then end our print line command. Okay, so we've got 2 closing brackets there because we've got 1, 2 opening brackets. Control 1, Control 2. Okay, so you can see our command's working, there's no errors. Let's see if we can make it a bit neater. So we're just doing Byron's car at the moment. So we'll get Byron's car working nice and then we'll look at the other cars. Okay, so %.2f. Let's make it so that our first column of data's got a width of, say, 20 characters, and our make's got a width of, let's have a look. So we've got 17 characters there, 18 characters in something reliable. So I'll make it 25 characters for our make. Tesla writes just only 14 characters. Okay, and we'll make it so our price is it's got 10 characters for space with a full stop and 2 decimal places, so 10 characters in total. And let's also put the comma separator in for thousands to make it a bit more readable. Okay, so put a comma there. Control 1, Control 2. Ooh, we've got a format conversion. And it's picking on the 1. Okay, so you've got to make sure you get your formats right. And it just takes a bit of playing. Let's try 10.2. And that's working fine. So 10.2. So where do we put our thousand separator? Well, you just got to play around. It might be here. Maybe you put it there. Okay. Maybe you put it there. Okay. So you just got to do what you can to keep Java happy with the formatting. Control 1, Control 2, and now it's working great. Okay, so if you use a format that doesn't work, just play around with it. Have a play. Have a look at the textbook. Have a look at some examples in the textbook. Okay. So comma 10.2f gives us 10 characters in total for price. So 10 characters in total, and including in that is a comma separator and the full stop and the decimal places. So 2 decimal places coming out. Okay, so we've really only got six characters or so for the number. So maybe we want to make that a 12. Okay, give yourself some more space to cater with big prices. Control 1, Control 2. That's looking pretty good. We probably don't want the semicolon there now. We'll probably take that off. And also notice the data is not on the margin. Okay. So when you go 25S or 20S, that means it's right justified. If you want to make it so it's left justified, you put a minus sign in. Okay, that means it's left justified. So minus means back further on the left. Control 1, Control 2, and that's looking pretty good. We could put a dollar sign here. There's a dollar sign for our price. Okay, so let's now fix up Jared and Liam's cars as well to use the same formatting. And we just got to copy that and go paste and paste. And so it's Jared's car and Liam's car and Jared's car and Liam's car. So just comment these out for now. We don't need these anymore. Control 1, so we've got Jared, 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 Liam, Liam, Liam. So everything's been copied okay and changed. Control 1, Control 2, and everything lined up nice and neat. So look how much neater that is now. Just a little bit of formatting, going on. Let's also add some headings. So we've got headings for columns. Okay. And we'll use that same formatting string. And it's owner. And the next string is the make. And the third string is the price. Okay, so we're not outputting a floating point number anymore, so we need to change this. And we know our field is 12 wide with a $sign, so 13 in total. So we need to make this a 13S and left justified. Okay, so that should be pretty close. So it's 12 for the number plus 1 for the $sign, just to bring it over onto that left hand. That should be pretty close. We'll have a play and see. Control 1, Control 2. Oops. Oh, I left off the percent sign. Percent. The $sign, not the percent sign. Sorry. There we go. Then see it's lined up right over the $sign because it made it so it's the right width. Okay. If you want to add some underlines as well, add some underlines. Why not? So we've got 20 characters for 5. 10, 15, 20, that's 20 characters. That'll bring us right up to the next column. Let's take 2 off, just to leave a bit of a gap. Okay, make is 25 characters wide. So we've got 5, 10, 15, 20, 25, and we'll take 2 off. So and then we've got price, which is 13 characters wide. So we'll just make that 5, 10. We'll make that the full 13 so that our dashes go right across over the decimal points as well. In fact, might as well put a couple of extras on as well. It doesn't matter. It won't truncate. If it's 13, it won't truncate. It's the minimum width. Control 1, Control 2, and there we go. If you do want to end right on a decimal place, you can take those extra 2 off and make it 13 wide again. Okay. And there we go. That's pretty neat. That's almost a report you could print out and show to a client. Almost. You could put some headings on and play around with it some more, but that's pretty close. Okay, so one thing we're doing here is we've got all this stuff, all that, and all that, and all that repeated multiple times. And we've got the price and that, and all repeated multiple times. So why don't we add a toString method? Okay, that's where toString comes in. It saves us repeating all this code every time. Okay. Now we've done something extra. We've added an owner in as well, and that's not part of our class. So owner is something we've added in extra. So we really want our toString method to work only with the class data, or else we could pass in something extra as well to get it to do it. We might even do that. So we're going to add two new methods. We're going to add a toHeadings or getHeadings method. Okay. So we'll cut that and paste it up here. Public string. You can call it getHeadings if you want to. That's going to, or print headings. Print headings. That means it's doing the printing as well. Okay, but if you want to control where the printing goes, if you want to put it into GUI components or into the console screen, you might not want your class printing out data to the console screen. So maybe you want to return it as a string. Okay, so we've got a string method there, so return it as a string. So we'll return that. Plus Okay, so we want a new line between them, /n plus. So we're doing the first row of headings plus a new line, plus the second row of headings, which is the underlines, and then returning that string back to the calling method. So I'll call it get headings. Okay, so now down in here, we can say system. In fact, let's not type it all again. Now you're going to notice something goes wrong here. Okay, there's something missing. Let's do a compile and see if we can work out what it is. And it says error, non-static method heading, non-static method get headings cannot be referenced from a static context. Okay. So it's saying this method here cannot be referenced from a static context. Okay. So what's going on is it's a class, it's an instance method of the class. Okay. So it wants us to use a class object to call it. We've got to say my car, or Byron's car, or Jared's car, or Liam's car. We're going to use a class object to call it. But we don't really want to call it for Byron's car or Jared, because we don't know what cars are there until we create them. Okay, so we just want to use a general purpose class car. So you could create a dummy car if you wanted to, or why don't you just make the method an instant or a static method? Okay, so it'd be car dot. Let's make it an instance method and get rid of that error. Okay, so now we'll make our get headings method a static method. Okay, static, public static string. Okay, so we've created our first static method that's not a main. Okay, so now we can call it for the class as a whole. So car dot instead of object dot. Okay, so it gets rid of that error. Car dot. Okay, so we just made it a static method. So it doesn't have to be called for a class object now, it's called for the class. So whatever the class name is, dot method name. Control 1, Control 2, and you'll see it's working beautifully. There's our headings coming out. Okay, so we're putting all our data that produces the output into our class. So it makes our main program simpler. Okay, so put all the common things that people want to do with our class, all the sort of functionality that might be useful, we'll put that into the class, and that makes their main programs whenever they use our class much simpler. So that's what we're doing. Now we do have a little issue here that with our example, owner isn't class data. Okay, so really we shouldn't be talking about owners inside this class. But what we could do if we wanted to is we could add another class field. Okay with the users, of course, and okay with the users, but maybe it's not okay. So we might have to take this one out and just have make and price. Okay, because it is. They might not want the owner in there. So really to stick to the spec, we should just be outputting data for make and price. Okay, so I'll reduce that down again. Just make it so the class deals with the class data. If this is a real class for a real client, we could ask, do you want to add the owner in? But we can't just go and add it without asking them, because you can't just go and add more functionality whenever you feel like it, because people might not want it. And people might not want you working on it. You might get sidetracked for weeks and people say, what are you working on? Oh, this new stuff I thought would be useful. No, we didn't want that. What are you doing? Okay, so you got to be careful. So we just make it so it just deals with the make and the price. Okay, so when we call it, so now we'll do our toString method. So let's do a toString. That's the next part of the question. Create a toString method. that will return a string representation of the make and the price. Okay. So public string toString. We're returning a string, so it's going to be returning a string. And it's going to return string.format. We don't have the owner anymore, so we take that out. So we don't have Byron's car anymore. We got the make and the model. Okay, but what car are we talking about here? It's not Byron's car, is it? Because Byron's car only exists in the main method. Okay, so we can't say Byron's car. It's just got to be the current car. So you could say this, if you want to, for the current class object. Yeah, so get make and get price. Or if you don't want to do that, you could say just get make and get price. That's quite okay as well, because Java understands you mean for the current object. So whatever object called this toString method will get its make and its price. Or if you don't do that, there's another way. And you can just use the class data directly. Make and price. Okay, because this is a class method, you can access the class data. Okay. Out of those three methods, I probably prefer the first one. It makes it really clear that that you're getting the make and the price, and you're using the accessor methods to get it. So if there's any rules or validation or anything issues going on with getting the data, these methods can enforce it. Okay, if they do any formatting or any validation or checking or retrieval, they can do that. They can do their work to get the price and the make that you need. In our case, it's just simple data. So this one here works perfectly as well, but I tend to prefer doing it that way. So toString. So now we can reduce all this code down. Okay, I'll leave the old code there. Call it for a class object. So Byron's car.toString. And Jared's car toString and Liam's car toString. Okay. So we don't know what car it is yet. So we could add that into the print line if you wanted to. Plus /n plus. Okay, so we've still got to do some fiddling ranks. We've got to work out. We've got to tell who the owner is on the screen if we want to know the owner. And same for Jared's car. And same for Liam's car. Okay, so we're going to see Byron's car come out to the screen, followed by the details on the new line, and then Jared's car come out to the screen, and then the details on the new line, and then Liam's car come out to the screen, followed by the details on the new line. Okay, so the new line coming out here. Okay. Let's run it and see what we get. Okay, it says Byron's car, something reliable. There's Jared's car, a Porsche, and Liam's car's a Tesla Roadster. Okay, so car.getHeadings gets us the headings. And it's called for the car class, not an object of the class, because it's a static method. Because you don't really need an object of the class to generate headings. You don't need to know whose car it is, because we're not accessing any class data. So make it a static method. Okay, then you can call it for the class, not an object. And then down here, we're calling Byron's car.toString. Okay, so the data for Byron's car is going to get displayed via the get make and the get price and the string format. So it's going to get returned, and then we're printing it to the screen. Okay, so you can see we reduced a fair bit of code down to something that's much shorter. Okay, and if we had more class fields, we could reduce it. This would be much bigger, and so by doing it this way, we're reducing it even further. Let's take out our toString for a second. Is everyone with me so far? Any questions so far? Is this confusing? Do you want me to go over anything again? I think we did a fair bit of this in week 5, but that was 2.5 weeks ago or so now. So is everyone okay? Okay, let's take out this method for now. So we're going to remove our toString method. What will happen down here? What will we see? Actually, let's go back a bit. I'll make it a bit easier for you. What will we see on screen? Don't have to give me the exact answer, just general terms. What will we see? Okay, so no one typing anything. So we'll see Byron's car, followed by a new line, and on a new line there'll be the name of the class, which is car, followed by an ampersand, followed by some strange hexadecimal number. Okay, and I'm just making up a number here, but it could be anything. Something like that. Okay. And that's the address inside the Java virtual machine of where Byron's car lives. Okay. So what Java actually does here is it looks through. It actually goes to the parent class. We can't talk about inheritance, but it's actually calling a method that returns a string representation of the data, and the only one it can find is one back in a very early class in Java called the object class, and that returns the class name followed by an ampersand followed by the memory address or the hash of the data. Okay, so that's that bit of code there actually lives in the object class. It's a toString method. What about if we put .toString there? What will happen? Any guesses? Sort of gave the answer up here. So we'd see just the same thing. Whatever that hexadecimal number is, we'd see it again. Okay, so when Java looks for a string, when you're trying to output to the screen, Java wants a string representation of your data. So it goes back and finds this toString method it can call. Okay, which in this case, because we don't have any in our own class, we commented it out. Okay, it goes back and uses the object class toString method, which I can't really talk too much about because we need to do more Java. Okay, so here we need a string representation of the data. So the object class toString is called, and that produces a class name followed by an ampersand, followed by a magic number of where the data lives. And also when we call a toString, we've commented out the toString in our own class. So Java goes back again and finds a toString it can call, which is the object class, and it runs a toString method in there, which returns the class name followed by an ampersand, followed by the magic number. Okay, so both of these things will produce the same thing. It'll be a different number to that. I'm just making up a number. But let's have a look and see what it generates. And then you'll see it's generated the number. Okay. So car followed by an ampersand followed by a magic number. Okay, so the one without the .toString there did the same as the .toString. Okay. Let's put our toString back in. Who can have a guess of what will happen? This same code. This one here should give us a string representation of our data. It should run our toString method. Okay, I think everyone should probably agree on that. But what will this one do? Will it give us a string representation of our data? Will it automatically call our toString method? Okay, let's have a look. And there it is. So even when we don't put the .toString there, Java automatically calls our toString method. how does it work? How does it know? How does it know to call it? Let's change the name of our toString method. Let's call it getString. Okay, or display or something. Okay. Now this one won't work, so we're going to call getString. Okay, and this one here. Actually, let's call toString as well. toString, string, which isn't part of our class, and let's also call getString. So what will happen here? We've got a method that returns a string representation of our class, but it's not called the magic word. It doesn't have the toString in the title. Okay, so here we're going to see this sort of thing going on again. Okay, and here, because there's no toString in our class anymore, we're going to see this sort of thing going on again. And here, Java knows to call the getString, so we'll see the string representation of our data. So we should see two outputs where we've got that strange number going on, and one that's our real data. And that's exactly what we get. Okay, so there's our strange data coming out because it's calling the object class toString method, which returns the class name followed by the ampersand followed by the hex number. And then down here, we're calling our getString. Okay, so what I'm showing you here is that the toString method is a special method in Java. Okay, a special method. And so if we go back and call that toString, watch what happens. So just change that back to toString. Oh, there's no more getString, so I've got to comment that out. GetString's gone, so it's just toString now. Control 1. And what do you think will happen? Do you think the toString will be called here? It will definitely be called here, but do you think it will also be called here? We're not calling it directly. Okay, and again, that's what happens. So whenever Java needs a string representation of your data, it automatically looks for a public string toString method. Automatically. Okay, so here it automatically calls toString, and here we've named it, so it's definitely going to call toString. That's pretty cool, eh? Whenever you need a string representation of your data in a GUI, in a label, in a GUI label, in a GUI text box, you can just go set the string in a text box to this field, this object, and Java automatically calls toString for you. Okay, and the whole reason is that there's a parent class. We don't say anything. We've got no parent class mentioned here. We don't specify parent class. And in Java, that means everything the parent class is the object class. That's the parent of all classes in Java, even when you don't specify any parents. So the object class is still there lurking behind the scenes. And so we're overriding the toString method in the parent class by supplying our own. Okay, so this one gets called if it's there. If Java can't find it, it calls the one in the parent class, which is the object class, which gives us that class name ampersand followed by that strange number. Let's take those out and put these back in. Okay. So we should be able to say toString or not toString. You should be able to leave that toString out. And I'll prove to you that's the case still. For all the objects, it doesn't matter which object. Control 1, Control 2, and there it is coming out. So we've got Byron's car, Jared's Liam's, Byron's, Jared's Liam's. Okay. And because I got you a good deal on the Tesla Roadster, Liam, I'd like to have a drive later if I can. Wouldn't mind having a drive on one of those. Okay, so any questions on anything we've done so far? Is anything strange, anything not sure of? With all this sort of stuff, you've got to play with it yourself, you've got to do it yourself, write the code yourself, play with it and pull it apart and follow the things I've just been doing, and it'll become clearer. Okay, no questions on the window. So we've done that. We've done that. We've done the get and set methods. We've created the toString method, and we've put them all through their paces to test them all out. Okay. Actually, we might not have tested one of the constructors. Tested that one, that one. Yeah, we're going to test another constructor. So we'll add another car in. Let's add a Mike's car. Mike's car. And I'm just going to pass the price through for that one. And I got a $999 one. Okay. So I'll put Mike's car. I quite like using the, I quite like naming toString there, but you don't have to. So I quite like using the first version. It's better to be specific of what you mean, I think. Mike's car, we're going to set the make for Mike's car. So Mike's car dot set make. It's an old rattler. So with set price, set make, set price, set make. Tested out all the constructors, and I think we're pretty good. Got the toString working. Got another method. We had another method in called get headings. We made that a static method, so we did something extra. Control 1, Control 2, and there we go. So there's Mike's old rattler, and it's $999. Okay, any questions on that one before we move on? Silence. So please do that question on your own and follow through the same sort of steps I did. Create a toString, give it a different name, add it, get headings, make it static and non-static, have a play, and things will slowly make sense. Okay, so. Next question. Okay, so we've got the review questions, and get those. Might do some review questions, try and get some dialogue going. So it's page 236 in my textbook. 236, go away. 236. Twitchy mouse. Okay, so first question. The code between a pair of curly braces in a method is a? You can speak if you like, or type. Yep, Jared's got it right, so block. Yep, perfect, so number B. When a block exists within another block, the blocks are, what's the word for it when there's a block within another block of code? Nested, perfect, Jared. Yep, that's right, so number B. The portion of a program within which you can reference a variable is the variable's what? So it's looking for the right technical term here. Okay, so what's the, yep, scope. So Jared's got it again, so scope. So the other 9 people, can you see if you can answer some of these? That'd be good to get some involvement going. Byron and Jared have answered a lot, so see if some other people can join in. That'd be great. So it's the scope. So, I mean, domain's a fair thing to call it, and range and space, the domain space or the space of a variable, that's all fine as well. But the correct technical term is scope. Okay. You can declare variables within the same name multiple times. So you can declare variables with the same name multiple times. When can you do that? See, within a method. Yeah. Okay, so this is, right. Okay, so Jared's Boris just typed something there. I'll paste it in. So Byron's pasted. None of this is correct, but you can do it with shadowing between class variables and method names. Yes, you can do that for sure. Okay, so so the question there says within a statement. That's certainly not true. Within a block, that's certainly not true. Within a method, and you can do it. So if that would certainly be okay. But I don't know if I would call that within the method, because it's something that's outside the method and something that's inside the method. So that's sort of not really within a method. Again, if you try and do that, that's not legal, so you can't do it within a method that way. But you can do this. This would be an error. Oops, sorry. But this would be okay. So, so you can do it within different blocks within a method. So, okay, different blocks. In other words, separate, not overlapping blocks. In a method, so that's okay. You can't do it without having them with the same scope. They've got to have different scopes. That's okay. That way still it's okay as well. So let's look at our answers. Within a statement, that's wrong. Within a block, that's wrong. Within a method, that's wrong. You can never declare multiple variables with the same name. Well, we've just proven that's wrong as well. Okay, so my answer to that question would be E, none of the above. None of those answers are correct. Okay, because we just proved you can do it. Yeah, we don't have an E. Exactly right, Sanjin. We don't have an E. So out of these four answers, if you had to choose one, if you've got to choose one, probably the one I would choose would be D. If I was forced to choose it, but I would hate to choose it because that's not correct. We've just proven it's wrong. You can have it here, and you can also have it here. So we've proven you can do it. But for the answers that are given, none of those are right. So if you've got to choose one, you've got to choose D. But yeah, don't like that answer. The only answer is none of the above. If you declare a variable as an instance variable within a class, and you declare and use the same variable within the method of the class, then within the method, okay, so we're talking about this situation here. We've got a class field or instance field, and a field declared inside a method either there or down here. Then within the method, the variable is used within the method takes precedence. The class instance variable takes precedence. The two variables refer to a single memory address. An error will occur. So which one of those is right? Number 5. Jared said A. Anybody got a different answer? Any other options? Okay, Jared, I like your answer. Jared, you're right. You're quite right. So the local variable takes precedence over the class variable or the instance variable. Okay, so it's quite right. A method variable so what does it say when a method variable just does something to a class variable with the same name? Sanjin said C. So C overrides. That's quite right. Yep. Yep. So when you've got a class field with a name, yeah, it's similar to the previous question. That's quite right, Jared. Yeah. And name there. So it overrides it, or you could even say shadows it. Shadow variables going on, sort of thing. Okay. So non-ambiguous overloaded methods must have the same. So non-ambiguous, they're they can't be confused with each other. Overloaded, so they're got special property there. Methods must have the same what? Which of those is right? Which of those is most right? So Sanjin said name. Okay, anybody else got a different answer? Okay, I like that answer. Yep, Jared says name. I vote name too. So they've got to have the same name. What can't they have? What's got to be different about them? So 7A. Must have the same name. What can I have that's different? Or what must I have that's different? So it's so parameters. So the data types in brackets. So you can have you could have a method that takes a string and an int. And you could have another one that takes an int and a string. That's okay, because they could be the one that takes a string and an int's different order of data, so that's okay. You have one that takes an int and one that takes a string, and maybe one that takes nothing, if it can do its work without nothing. So all of those are valid. They're all overloaded, non-ambiguous methods. Okay, and which one gets called depends on the data you provide and the order you provide it. So if it's a string and an int, this one will get called. If it's an int and a string, that one will get called. Okay, so overloaded methods have got to be non-ambiguous. You can't have ambiguous overloaded methods. Otherwise, Java will give you a compilation error saying, I can't work out which one to call. Okay, so they've got to be non-ambiguous. So the first part of that question was a bit of a red hat, or something that wasn't really needed. It was just superfluous, because overloaded methods can't be ambiguous. Java's got to be able to distinguish between them. And would this one be okay? If I had another method that took an int, that returned an int, would that be okay? The return type's different, so surely that should be okay, shouldn't it? Anybody agree? Okay, so I got a question there from Jared. We'll just finish this one first. So that would be an error. Okay, the return type doesn't matter. Okay, it's all on the types of the parameters and the order. Okay, so that would definitely be an error if you put an int there, because you've already got a method that takes an int. Okay, so ambiguous. Let's go on to Jared's question. If the method accepts an int and a string, it would be an error if you put a double, and that's correct, it would be an error. Okay, so this method here. That would be an error because Java can't find a method that takes a double. Ah, yes, but the other way around, it would promote the int to the double. That's correct. Yep. That's correct. Yeah, that's good. No, I like the I like the questions and getting feedback. That's great. Thanks, Jared. You're asking some good questions. And here we go. Straight onto the question as well that you just asked. So you've got psychic ability. If a method is written to receive a double and you pass an integer, then the method will, what will it do? And yeah, so Jared knows the answer. Yeah. Sanjay knows the answer. Good on you. That's right. So quite right. So it will do number A. So to work correctly, and the integer will automatically be promoted to a double. Okay. And no warnings, no error messages. Java just does it for you. Okay. The other way around, if you try and provide a double, it won't automatically convert it to an int because it's going to lose precision, and Java will give you an error saying cannot find a method that takes a string and a double. Okay, so that will be an error. How could you fix that error? At least, how could you chop off the decimals to make it so Java accepted the value? There's a few ways we can make it so it's acceptable. So we can put something here. And also we can call a math function. Anyone remember what those functions were, or what we put here to make it so acceptable? Okay, so we put an int, we do typecasting. We're converting the double to an int and passing the int across, and then Java's happy. Java's happy then, because you converted the double to an int. Okay, and the other way is you could do a math.round. Round it or truncate it or whatever you want to do. Okay, so there's various functions here you can call. Okay. So you just need to check that did return math class. Let's just check it does return an integer. So math.round. Math.round returns a long. Okay, and so again, you'd probably get an issue there saying, you know, possible loss of data because you're trying to pass a long then across as an int. So you might need to still do a for that. So you also just do it that way. Okay. Oops, a constructor, something parameters. So a constructor can receive, cannot receive, must receive, can receive a maximum 10. What's the most correct answer? Okay, correct, can receive. So a constructor can receive. A default constructor cannot receive any, but just a constructor in general terms can receive, you know, a parameterized constructor can receive 1, 2, or as many as you like. You can pass through thousands of parameters if you want. If there is a limit, I don't know what it is, but there may be an upper limit, but it's huge. It's beyond reasonable. Okay, so I've never hit it. All my years of coding, I've never hit it. A constructor, something overloaded. A constructor can be, cannot be, must be, is always automatically. Which of those is most right? So a constructor. Okay, so a constructor can be overloaded. And we saw that with our car example. We've got a constructor there, another constructor, another constructor, another constructor. So we've got overloaded constructors, and which one gets called depends on whether we pass parameters and the order of the parameters or whether we pass no parameters. Okay, So they're all constructors. There's 4 constructors there. This one here's got the special name of being default constructor. These ones have the names of being parameterized constructors. And I usually call them number 1, number 2, number 3, whatever. So they're still all constructors, so they can all be overloaded. You can have as many as you like, as many as make sense. Okay. Usually you want each instantiation of a class to have a copy, its own copy of, what do you want to have its own copy of? So by class methods there, I mean the static methods. So the data fields, in other words, the instance fields, or the class methods, and by class methods, they usually mean the static methods, not the instance methods. I think that's a really unfortunate term to use class methods and static methods to mean the same thing. But that seems to be the way most of the books are written. So both of the above or none of the above. So for 11, if you mean class methods, static methods, then which is often what people say when they mean class methods, say class methods in Java. I think it's, like I say, I think that's really unfortunate, but that's the terminology that they're using. So the only one you want to have a copy of is your data fields or your instance fields. You also want to have your instance methods. Instance methods and instance fields go together. And so Mike's got his own copy of the data, and Jared's car's got its own copy of the data and the instance methods, and so on. Okay. So, so the most correct answer there is A. If you create a class that contains 1 method and instantiates 2 objects, you usually store. Okay, so behind the scenes, Java does all sorts of optimization, where if it's got a method, it doesn't keep multiple copies of it. Okay. So really, this is a difficult question to answer for us at this stage, anyway, with our knowledge of Java. But if you create a class that contains 1 instance method and you instantiate 2 objects based on the class, then you usually store what for use with objects. So 1 copy of the method, 2 copies of the method, 2 different methods containing 2 different this references, the data only, the methods are not stored. Okay, so for this, the most correct answer for what we know so far is C. Okay, so C is the most correct answer. 2 different methods in 2 different parts of memory, each their own access to the local data for the class. Okay. Now Java might do some optimizing where it reduces the method code down to, and it works out what the this reference is for each object, but that's internal to Java. So the most correct answer there, I would say, would be number C. For this reference, which of these is most correct? Any answers there? Can be used implicitly, must be used implicitly, must not be used implicitly, must not be used, must not be used. And what do we mean by implicitly? What's explicitly and implicitly? Can anybody write anything that would show me implicit and explicit use of the this keyword? So you've got to think about all these sorts of things. What does implicit mean? What does implied mean? What does explicit mean? These things sound complicated until you can think of an example, and then you can make a lot more sense. So try and think of an example. No examples, nothing in the chat window. Okay, so let's have a look. A name. Okay. So here we've got implicit this. Okay, this name field here is our class one. So really behind the scenes, Java's, that's exactly the same code as this. I'll put them together, I'll comment one out. Okay. Here we've got an implicit this. Okay. It's just taken as read, you mean for the current class object. There's no data field called name here. That's not called name. There's nothing declared in the method called name. So Java looks back into the class fields, the class instance fields, and it finds that one. So yeah, okay. So you obviously mean for the current class object. So that's an implicit this. And this one here is an explicit this. You're making it really clear. Okay, so explicit and implicit. Implicit means it's implied. You just take it as read that it's there. Okay, I'm using name. There's no local field called name anywhere in this method, so I must be using the class field. Okay, so it's for the current class object. So there's an implicit this there. Or else I can make it really clear. That's what I mean by saying this dot. Okay, so implicit and explicit. It sounds really complicated until you can think of an example like that, and then it all becomes clear. Hopefully. Hopefully. Any questions on that one? We've still got eight people here. 8 people still here, so we've got still got a few. We got up to 11, but we're down to 8. Not everyone can stay the whole time. That's fair enough. I just hope they catch up with it when it's recorded. Okay, let's have a look at our question. So this reference can be used implicitly. Yes, that's true. Must be used implicitly. No, that's not true. We've just seen here that you don't have to use it implicitly. You can use it explicitly. Must not be used implicitly. We've just seen that's false because we just used it implicitly. And it must not be used. Well, we've seen that's false because we've used it. So the only possible correct answer there is A. Okay, so if this is an exam situation and you got this question and you couldn't remember and you didn't want to go through 300 pages of the textbook trying to find the answer, you could just think of it a little example. Write some code like this. Okay, and then you got the answer. The answer falls out straight away. Methods that you reference with individual objects are, okay, so methods that you reference or call or invoke for individual objects of the class are what sort of methods? Okay, so methods you reference with individual objects. So for 14, we're talking about this object method. Object dot method. So what are those methods called when it's object dot method name? Nobody? Nobody? Oh, here we go. Okay, so I've got a question there from Sanjin. I'll come on to that next, Sanjin. I'll just finish this question first and then we'll answer your question. Okay, so if they're object dot method name, then they must be instance methods. Instance methods. Or in other words, non-static methods. Static. Okay. So that's the correct answer. D. They must also be public, because if you're calling them from outside the class, using them for individual objects, they must be public. So out of those two questions, two answers, B and D are correct. But I think what they're really looking for there is that they're non-static methods. I think that's the most correct answer of the two. But B and D are certainly correct there, because you're using them for individual objects outside of the class. So they must be public and they must be non-static. If they were class name dot method name, then what sort of methods are they? When it's class name dot method name. Anyone remember the name for those? Hint, it's the opposite of that. Okay, so they're static methods. Okay. On to Sanjin's question. Might be late to ask this question, but about assignment submission, are there any limits or conditions on the format of the words for the report for the Word document? Now, as long as you provide the things that are required, so the key thing that you need to do is a title page with your name and course and that sort of thing, student ID, and then include your testing. So you need to include what problems you had. So a little summary of the problems you had, how long things took. I really had problems with a semicolon after a for loop. It took me a while to check down that's what I was doing wrong. I had a problem with getting scanner input. And then I checked some tute questions, I did this, and then it came back, it all became clear. I had problems with loops, all that sort of thing. Just describe briefly any problems you had. And the reason why that's asked for is that we actually look at the problems people had and we make the course material better next term. Okay, so if a few students have a problem with something, we make the course material better. Add some tute questions in, add a bit more explanation on the lectures. Okay, so we do look at the feedback we're getting from those. And then the next question is, the next part of the report is, you've got to do screenshots of your testing. So get your program reacting to inputs, invalid inputs, valid inputs, get the error messages being showed, add a bit of text below each screenshot to show what's going on. Okay. And the last thing is the format. The format in the words generally is up to you. Okay, but do a title page, do your summary of your problems you had, then do your testing screenshots, which might be 5 or 6 or more pages. And then you've got to do your appendix as well. And don't forget your appendix, which is all of your source code copied into the document. Okay, so as long as you follow that rough sort of format and keep things nice and neat and answer all the parts that are required by the assignment spec, you should be okay. Okay, but the exact format and the exact sort of words you need to use, it's really up to you to decide on that. Just as long as it's neat and tidy, have your headings nice and clear. And we're coming into the last 10 minutes. We might just go back, because there's been some, I think some people arrived late, so we might just go back to the very start and talk about what we talked about at the start of the tute. And in week 5 and week 6, I usually sit with students and have a quick look through your assignments, see if there's any glaring issues, see how you're going, any problems, anything I can help with. But I try and make sure I do it with every student in class during week 5 and week 6. I usually do it in week 5 and again in week 6. And I don't help you directly on your assignments, of course, but I can show you, if you've got problems with this, I'll show you, how to do it with a tute question, or recommend a tute question, or something like that, and then once you've done the tute question, then you can come back and, everything in the assignment makes sense. Okay, but I can't do that because of coronavirus. So if anyone's got any issues with their assignments, any questions, I can't help you directly on your assignment, but I can explore and work on other similar problems, tute questions and textbook questions and whatever. So if anyone's got any questions there or issues, anything they got stuck on, any errors they can't fix, anything like that. Okay, so you really want to sort them out now. You don't want to leave them until 10 o'clock tonight or 11 o'clock tonight.
I think I actually do have one about the scanner thing.
Okay.
So I'm actually using Eclipse, not TextPad, because, well, there are some issues with installation and those kind of things.
Okay, Eclipse is great. Yep.
Yeah. So I created the scanner object and used that for input. And when I tried to run the code, it showed not an error message, but a warning sign which says resource leaked. The scanner object is never closed.
Oh, okay, righto, right.
Yeah. Have you learned about closing the scanner? Or
No. It's just a warning. But yeah, ideally for every object you create, you should close it as well. Okay, and but Java does take care of a lot of that for you automatically. If we're writing in C or C++, every time we create an object, we're gonna erase it at the end. to be a good programmer. Okay, but with Java, there's an automatic garbage collector which does clean up for you. So I think that warning from Eclipse there is just being super cautious, and I think you can ignore it safely. That's quite okay.
Okay.
Okay, another question here from Jared. I'll put it into the window. I have a loop using a Boolean and a couple of if statements where I've repeated code a couple of times to validate string data. Can't really figure out how to remove the repeated code and make it work. Okay, so we did talk about validation in, I think it was week 3, week 4. We had a big validation example where I showed you various ways to do it. And we basically came down to this sort of thing. So we said Boolean and while valid equals false. Write pseudocode or comments if name not valid, display error, set data valid to true. So you can do your validation for name, and then if you've got to get a score or something from the user, you set data valid to false again. So assume it's invalid. And then get the next piece of user input from the user. So you might be getting email address user. If the email is not valid, display an error and display an error, else set data valid to true. Okay, so you'll keep looping while data valid's false. So you do that for all your inputs. If you had another input to get date of birth, DOB from user. And if date of birth not valid, display an error, otherwise set data valid to true. And eventually you'll come down to do your processing. So if you get down to here, everything's valid, and then you can just do your processing. Okay. Now, you got to loop 9 times or 8 times, depending on your student ID. So all of this code here might be in a great big loop. You see what I mean? So you might have the whiles. You might have all of this in a great big loop. Because you've got to do it 8 times or 5 times or whatever it is. Okay, so Jared's just saying he had I had an if and then a while and then an if again. If you want to have a look at your code and give you some advice, send me an email with the code outside of class, and I'll have a look at it and just give you some advice if you like. If anyone else has got any issues and want to have a quick look at it with their code, you can email me your assignments and I'll have a quick look. I won't do a full mark, of course, and that. But if you want to have a quick look at your code, I'm happy to do it. Certainly, if you're having issues or you've got questions, you're not sure this is the right way to do it or whatever, and but do it. Do it soon. You know, straight after class. Don't leave it till 10 o'clock tonight or 5 o'clock tonight or 6 o'clock tonight. That's too late. I'm not going to be checking my emails all through the night. Okay. Jared says he'll send it now, so that's perfect. Okay, so if you do need help, send code now, not later today, not tonight. Okay. I think that's it for today. We've still got some tute questions to go, so work through those on your own. We didn't get to the textbook questions this week, so there's a fitness tracker, there's the form letter writer, there's the bread and sandwich question, and the maths tester as well. So if you could get to one of those, if you could only do one of those, I would recommend you did the form writer or the bread question, or the fitness tracker even. But the math testers, that's the one I wouldn't do. That would be the last one I do. But these 3 are definitely good questions. Develop your own data class and follow through the process we've done. It's like baking a cake. So when you create a class, you've got the constructors, and the setters, getters, and the toString, and whatever else you need that's in there that makes sense. You know, get headings and whatever. Okay, so you just follow that same recipe for every class you create. Just go ahead and create a default constructor and parameterized constructors, whatever makes sense. Setters, getters, and toString. Just do that with every class you create. Then have a little main method, usually in a separate class, where you put your class through its paces. So just like we did here. But usually this lives in another class, like called CarTester or something like that. So the main would usually be in another class, CarTester, and you'd test it from there. We can do that really quickly if you want. I'll cut it out of here. So it's no longer in our data class, and we'll move it into another class. Public class CarTester. Tester. CarTester.java. All the color coding's on, so we're good to go. So we can compile that and run. Control1, Control2. And there's the output still being produced in the CarTester. So that's a much better way to do it. Don't put the main in your data class, put the main in the tester class is a much better way to do it. So I think that's it for this week. So I'll go and check my email, and I'll stay on email for the next hour or so. So if you've got any issues, make sure you email me soon. And hopefully it won't be too much to reply to, but I'll do it if I can. And if the email I'm going to send you back is going to be really long, I might do a little private video that I upload that just you can access. Okay, so I might do a little video reply rather than a long email reply. It might be easier for you to see and for me to do. Okay, so anyway, thanks for coming along. Get your assignments in tonight. If you do need an extension, please ask for an extension. There's links on the course webpage. I had one student earlier in the term whose computer died. If you're using GitHub like I've been suggesting, or keeping backups, you should be ready to go on another laptop pretty quickly. But if you can buy a laptop, that's the thing as well. But just make sure you keep backups of your work. Keep backups and backups and backups every time you do something, every day. Okay, in multiple places. Back up to your email, back up to a USB drive, back up to an external hard drive, back up to somewhere else. Set up some OneDrive or some cloud storage and back up there. And then you can't lose any work. Okay, anyway, thanks for coming along. Stay safe, have a nice day, and see you next week. Get lots of coding in, get lots of programming. Okay, see you next week.